Hello students, welcome to online maths classroom. Today we are going to do sequences and series. Part 6 will include the solution of exercise 9.4, question number 1 to 10, which is based upon some special series. So let us start with it. Exercise 9.4 is having these 10 questions. They are on your NCERT book. First of all, we need to check out few important formulae and their proofs. So let us start with very first one, which you have already done in class 10th, that is sum to n terms of special series. Now sum to n terms of special series means the sum of first n natural numbers. You already know that it is given by n into n plus 1 by 2. Okay, so from 1, 2, 3, so on, so up to n, you know it is an AP with A1 and D1. Okay, and applying the formula of Sn is equal to n by 2, 2a plus n minus 1 d. Okay, if I'll put the value of a as 1 and d as 1, I'll get it as n into n plus 1 by 2. Okay, so we can write it as Sn is equal to this, or we can write as summation k varies from 1 to n k, that is when you will open it, it will be like 1 plus next number is 2 plus 3, so on, so up to n. So this way means if somewhere it is written like this, that means it is required to find the sum of first n natural numbers, which is n into n plus 1 by 2. Second is to find sum of squares of n natural numbers. Okay, so like we did sum of first n natural numbers, it is squares of first n natural numbers, like 1 square plus 2 square, so on, so up to n square, and it is given by n times n plus 1 into 2n plus 1 divided by 6. Okay, so let us see how it is proved. First of all, we'll consider the identity, that is k cube minus k minus 1 whole cube. Okay, k cube minus k minus 1 whole cube. When you will open it, it will be like 3k square minus 3k plus 1. Okay, you will consider this identity. Okay, now put values of k as 1, 2, 3, so on, so up to n successively, and what will I get? See, I will start with 1. So it will be 1 cube minus 1, that is 0 cube, is equal to 3 times 1 square minus 3 times 1 plus 1. Similarly, put k as 2, so it will be 2 cube minus 2 minus 1, that is 1 cube, is equal to 3 times 2 square minus 3 times 2 plus 1. Similarly, when k is 3, you will get it, and so on, so. Okay, and the last one is when I'll put k as n, so it will be n cube minus n minus 1 whole cube is equal to 3n square minus 3n plus 1. Okay, now I will add. Okay, add successively to all the entries towards this side and all the entries towards this side. So see how we are going to add. Now focus here. You will find when I'll add all these terms, so this 1 cube will be cancelled with this minus 1 cube. This 2 cube will be cancelled with this minus 2 cube. Similarly, 3 cube will be cancelled with the next one. Okay, so it will keep on moving like this. Okay, so definitely this last one. Okay, see the pattern. This 1 cube is getting cancelled with this. 2 cube is getting cancelled with this. So in this order if things will go, so this n minus 1 cube will be cancelled with the previous one. So I'll just get as n cube and this minus 0 cube when I'll add all of them. N cube minus 0 cube. Now come to the right hand side. It will be like, see, all these 1 square, 2 square, 3 square, so on, so I have 3 common, so it is 3 times 1 square plus 2 square plus 3 square, so on, so up to n square, minus 3 times 1 plus 2 plus 3, so on, so up to n, and plus 1 added n times, that is n. Okay, so I get it as n cube is equal to, now I told you how we can represent as in the previous proofing, that we can write it as 1 plus 2, this plus 3, so on, so up to n can be written as k varies from 1 to n times k, like it is, minus 3 times k varies from 1 to n k, plus this is n. So this will be written as 3 times summation k varies from n 1 to n, this will be k square. Okay, so that when I'll put values of k 1, 2, 3, so it will be like 1 square plus 2 square. Clear? Now the value of n cube is equal to, I'll get it as say 3 times k square. Now k square is my required term, so I'll keep that k square to other side. The term which was here like k square, I'll take it to this side, and the rest terms will be like n cube. Okay, and this is the value of that formula placed like summation k is your n into n plus 1 by 2. Okay, and the n is also brought to other side, so it will be minus n. Okay, means this is kept to this side, and rest of the entries are summation k is written like this plus 3 times n into n plus 1 by 2. Okay, as it was minus here, so when it will move to other side it will be plus, and the n was plus, so when it will be taken to other side it will be minus n. Okay, now take your 1 by 3 common, as this 3 will be shifting to this side. So 1 by 3 common, and rest is the just taking the LCM 2n cube plus 3n square plus 3n minus 2n. So it is 2n cube plus 3n square plus n divided by 2. Okay, so it will be 1 upon 6, and take n common from here. It is 2n square plus 3n plus 1, and after factorization I'll get it as 2n plus 1 and n plus 1. Okay, so I think it is very simple. You can factorize it easily. So I'll get it as n into n plus 1 into 2n plus 1 divided by 6. Okay, so this is the formula of sum of square of first n natural numbers. Now sum of cubes of first n natural number. So sum of cubes of first n natural number, that is 1 cube plus 2 cube plus so on so up to n cube. This is equal to n into n plus 1 by 2 whole square. Okay, for first n natural number we got as n into n plus 1 by 2, and for the sum of cubes I will get it as n into n plus 1 divided by 2 whole square. So firstly I'll consider the identity k plus 1 raised to power 4 minus k raised to power 4, and after opening, as there we considered of cubes, so it will be 4k cube plus 6k square plus 4k plus 1 when you will open it. Okay, you have to remember that you have to consider this identity. Okay, so when it was square we consider the identity of cubes. When it is cubes we'll consider this identity of power 4. Okay, now put again k as 1 2 3 so on so up to n. So again start putting it. So when k is 1 it will be 2 raised to power 4 minus 1 raised to power 4 is equal to 4 times 1 cube plus 6 times 1 square plus 4 times 1 plus 1. Similarly when k is your 2, so it will be 3 raised to power 4 minus 2 raised to power 4, and similarly this. And the last one for this is for n minus 1, so it will be n minus 1 raised to power 4 minus n minus 2 raised to power 4, like this. Okay, when we put k as n minus 2. Okay, and the last one is when we put k as say your n when it is k. Okay, we took some more terms here for clarification. The last one is when k is n. So it will be n plus 1 raised to power 4 minus n raised to power 4, that is 4n cube plus 6n square plus 4n plus 1. Okay, now again I'll add successively. So see, after addition what happens, see, this will be cancelled with this with the previous, this with the previous. So if I move like this, see n minus 1 4 is cancelled with this, and this n4 will be cancelled with this. So I took 2-3 more steps so that the if in previous question also things are not clear, so they get clarified. So this last one gets cancelled like this. Okay, so what we get, this n plus 1 raised to power 4 and the this minus 1 raised to power 4. And to this side 4 times 1 cube plus 2 cube plus so on so up to n cube plus 6 times 1 square plus 2 square so on so up to n square plus 4 times 1 2 3 so on so up to n, and plus 1 is added n times, so it is. So this can be written as 4 times summation k varies from 1 to n k cube plus 6 times summation k varies from 1 to n k square plus 4 times summation k varies from 1 to n k plus n. Okay, so this is your equation number 1. Okay, so again what will I do is I'll keep it to one side. Okay, I'll keep it to one side because I have to find this summation k varies from 1 to n k cube, and rest all these terms using the formula, because k square is that 1 square plus 2 square plus so on so up to n square. So I'll put the formula which I just derived, that is n into n plus 1 into 2n plus 1 divided by 6, and this will be taken to other side. This will be minus 4 times, and k is your n into n plus 1 by 2, formula of the very first proof we done, sum of first n natural numbers, and this will be when taken to other side will be minus n. So it becomes your this your 4 times this k varies from 1 to n k cube is equal to, I'll open this n plus 1 raised to power 4. Okay, all the things after substituting the value. Okay, so it is like your uh, n raised to power 4 plus 4n cube plus 6n square plus 4n minus your minus 6 times n into n plus 1 into 2n plus 1 divided by 6 minus 4 times this n into n plus 1 by 2 minus n, all taken to other side. Okay, so this is the expansion of n plus 1 raised to power 4. So it becomes 4 times the sum. Okay, you can write it as Sn. Sn means the 1 cube plus 2 cube like this. So all this minus again 6 cancelled with 6. Okay, rest multiply all the terms minus this 2 cancelled with this 2 like this. So when you will open it, everything will be there and you will get it as n raised to power 4 plus 2n cube plus n square. Okay, and this 4 divided to this side divided by 4. So I can take n square common from the numerator. So it is n square plus 2n plus 1. Okay. And you know it is n plus 1 whole square. So all combined in the square bracket, I'll get it as n into n plus 1 divided by 2 whole square. Now let us see question number 1. Okay. So question number 1 is find the sum to n terms of the series. Okay. So dear students, what we will do in these questions, as the questions which we proved earlier, they are the required formulae which will be using it. Okay, here for solving it. So first thing is to get the nth term. Nth term. So see this series. It is like 1 cross 2 plus 2 cross 3 plus 3 cross 4 plus so on. Okay. So first term is 1 cross 2. Second is this. So what will be the nth term? Nth term will be like n into n plus 1. N is a natural. N into n plus 1. Okay. So what is the nth term? This is nth term, that is an is n square plus n. Open it. Okay. So I have to find its sum. That is Sn is summation n varies from 1 to n. An. Okay. So who is an? N square plus n. Now separate the summation. It is same bracket here. Okay. Separate the summation. It is n varies from 1 to n. This is n square plus this is separate. Now n square you just did. It is the sum of square of first n natural number. What is the formula? N into n plus 1 into 2n plus 1 divided by 6. And this one is n into n plus 1 divided by 2. Okay. So I told you in an induction also that it is better when such kind of big results are there. It's better to take things common. So I can take n into n plus 1 by 2 common. And it is 2n plus 1 divided by 3 plus 1. Okay. You solve. Okay. And then you will get it as 2n into n plus 1 into n plus 2 divided by 6. And one more thing you can do is divide this, cancel this 2, and here it will come as 3. So it can be further reduced. Next is same question. Okay. So I'll just go it quickly because previously it was 2 terms. Now it is 3. So then a term will be like n, see, n into n plus 1 into n plus 2. Okay. As if it is the first term, then nth term will be n into n plus 1 into n plus 2. Okay. So all multiplied together will give me n cube plus 3n square plus 2n. Okay. Now summation is Sn is summation n varies from 1 to n an. That is, this is your an. So separate this. It will become summation n cube plus 3 times. Constant will be outside. Summation 3 times summation n square plus 2 times summation n. Now you know what is n. What was n cube? N cube is your that sum of cubes of first n natural number. That is n into n plus 1 by 2 whole square. N square is your this. Your summation n is this. Okay. Put everything here, all the values. You can take n into n plus 1 by 2 common, or you can take n into n plus 1 common also, howsoever you find it right. And rest terms are there. Okay. You just need to take LCM. Okay. And after taking LCM, you will get it as c n square plus 5n plus 6 inside. Okay. Do the factorization and I'll get the result as n into n plus 1, n plus 2 into n plus 3 divided by 4. Question number 3 is again, the first term is like, this is again sum to n terms of series. So first term is 3 into 1 square. Now observe the pattern. Okay. Observe the pattern. It is not alike. See, this one is the first terms. They are framing an EP. Okay. And this one is your like 1 square, 2 square, 3 square, so on. So it is the product. And a term is like nth term of 3, 5, 7, so on, so into nth term of 1 square, 2 square, 3 square, so on, so. Okay. Now what is the nth term of 3, 5, 7? So on, so. It is an AP. So AP, the nth term can be calculated with A3D2. So nth term is 2n plus 1. Okay. Apply the formula of A plus n minus 1d. And the nth term of this will be simply n square, as 1 square, 2 square, so it will be n square. Now, what is the nth term of this complete? It is nth term of this into nth term of this. That is your 2n plus 1 into n square. That is 2n cube plus n square. Now take the sum. Okay. So it will be 2 times summation n cube plus summation n square. Okay. So these are again the formula. You apply this formula. Say n into n plus 1 by 2 is common. Okay. Solve it. It's very simple. I think just taking the LCMs. And after taking LCM, from here you will get the equation 3n square plus 5n plus 1. Okay. And it cannot be further factorized. So I think this way also it is okay. So we get the answer as n into n plus 1 into 3n square plus 5n plus 1 divided by 6. Number 4. Now this is a very important question. Please pay attention, because in this question is a concept which you will be using in partial fraction, which you will do in your class 12th. Okay. So see the pattern, how the question is going on. So it's a very good question. Sum to n terms of this series. Now see, nothing is in the numerator. Okay. Nothing is the numerator. So if I go to the nth term, it will be like 1 upon, as you did in the first question, 1 into 2, that is n into n plus 1. So it is here like 1 upon n into n plus 1. Okay. But this way it is not easy for me to prove. Okay. I'll not be getting any formula to be applied. So what I will do is I will express this as, see, this 1 upon product as 2 terms. Okay. Difference or sum of 2 terms. So from here, can I write this 1 as n plus 1 minus n? Yes. 1 can be written as n plus 1 minus n. So now separate n plus 1 divided by this complete and minus n upon this. So n plus 1 cancel. So it becomes 1 upon n minus 1 upon n plus 1. So this is your nth term. Okay. Now what is the first term? First term is your 1 upon 1 minus this, that is 1 minus half. Second term is half minus 1 by 3. Third term is 1 by 3 minus 1 by 4. So similarly, your nth term is 1 by n minus, which is itself. Now add you as it added successively in the previous one. So when I will add, what is happening? See, now this way. In that question it was that way. Now this way they are getting cancelled. 1, 2, 1 by 3 with this with this, and 1 by n with the next one. So what is left? Left is just this first 1 and minus 1 upon n plus 1. See carefully. This get cancelled with this with this. So this will be cancelled with the previous one. So I get the first and 1 upon n plus 1. So this is just Sn. Now Sn, take LCM. It will be your n plus 1 minus 1 divided by this. So n upon n plus 1 is the required sum. Okay. Number 5 is 5 square plus 6 square plus 7 square, so on, so up to 20 square. Now dear students, see, it is not a question that you will square all of them and then add it up. Okay. Because this is, here you have to apply the concept of some special series. So series always starts from the first natural number, that is n. Now you find that the first natural numbers 1, 2, 3, 4, their squares are missing here. Okay. So what I will do is, to apply this formula in a very free manner, what I will do is, whatever is missing I'll give and subtract it. So see, I have added 1 square plus 2 square plus 3 square plus 4 square and completed this series up to 20 square, minus what I added, I subtracted 1 square plus 2 square plus 3 square plus 4 square. Okay. Now, the formula of 1 square, 2 square, so on, so up to n square is here, this. Okay. So here n is your 20 in my this portion. So put n as 20, you will get the formula as 20 into 21 into, say 22 is 40 plus 1, that is 41 divided by 6. That is 2870. And this can be, I think, simple calculation. This is 16 plus 9 plus 4 plus 1, and that is equal to your, or putting n as 4, that way also you can do. It is coming out to be 30. So my required answer is Yeah, 2870 minus 30, that is 2840. Okay, so this is very simple question, but don't forget to start from 1. Number 5 is again very simple one, so I'll quickly go for it, as this is again 3. If you see, this is the first AP. Okay, and a term is a plus n minus 1 die, that is 3n. Okay, and again second one, from here also you can see 3n means, and if I start from n as 1, so it will be 3, and as 2 it is 6. Okay, so it is like 3n. And second one is again an AP 8, 11, 14, so on. So again A is 8, D is 3, and n term is 3n plus 5. Okay, now since it is the combined, so n term is your this 3n into this, so this is 9n square plus 15n. So again apply the formula for this, so it will be 9 times summation n square plus 15 times summation n square. So 9 times summation n square, you know, n into n plus 1 into 2n plus 1 by 6 plus 15 times n into n plus 1 by 2. Okay, summation n. So just take LCM. Okay, take the things common. I can take 3n into n plus 1 divided by 2 common. From here I'll get 2n plus 6. Okay, so the overall answer is 3n into n plus 1 into n plus 3. Okay, because this 2 gets cancelled with this. Question number 7. Question number 7 is, find the sum to n terms of the series 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square and so on. Now observe it. The first term is having the square of first natural number. Second term is having square of 2 natural numbers. See from here. Third term is having square of 3 natural numbers. So nth term will be having square of n natural numbers. Okay. Now you know what is the an. This is the nth term. So sum of square of first n natural number you already know. It is given by the formula n into n plus 1 into 2n plus 1 divided by 6. So n is here this one. Okay. Now we haven't yet found the sum, but the nth term is obtained from this. Okay. Now open it, multiply, you'll get it as 2n cube plus 3n square plus n divided by 6. Okay. Now sum is summation of this an, that is 1 by 6 outside, and it is summation of, say, this complete term. So I can write it as 2 times summation n cube plus 3 times summation n square plus your n. Okay, 1 by 6 is common. So these are the formula. Already we are familiar with it. We'll substitute all the values. Okay, solve it, and after taking the LCM or taking the things out common, we will be getting. Now see what term is coming as next. So what can I take common is n into n plus 1 divided by 2. Okay, you can take n into n plus 1 divided by 12 as common, and here I get the equation as n square plus 3n plus 2, which can be easily factorized as n plus 1 into n plus 2, and this is the required answer. Okay. Okay. Number 8 is your, find the sum to n terms of the series whose nth term is given by this, n into this. So nth term is given, so I'll just put multiply all of them. So an is your n cube plus 5n square plus 4n. So what is Sn? It is summation n cube plus 5 times summation n square plus 4 times summation n. Apply all the formulas which we know already. Okay. You can take whatever is maximum common. So I'll get the common as n into n plus 1. Okay. Take it in one bracket. Open it. We get the quadratic as 3n square plus 23n plus 34. Okay. So if it is factorized, then factorize, but I don't think so. It can be further factorized. So I'll leave it as it is. So the required sum is n into n plus 1 into 3n square plus 23n plus 34 divided by 12. Next question is, find the sum to n terms of the series whose nth term is given by n square plus 2 raised to power n. Okay. So let us start. This is summation n square plus 2 summation 2 raised to power n. Now see here. This I know. This formula is very simple. This formula is very simple. This is your simple, that is n into n plus 1 into 2n plus 1 divided by 6. But this one, see, if I open it, like put the values of n, 1, 2, 3, so on, so up to n, it will be like 2 raised to power 1, 2 square, 2 cube, so on, so up to 2 raised to power n. So it becomes a GP with A as 2 and R as 2. Okay. And you know, R is 2, which is greater than 1. So what is the sum? It is A into R raised to power n minus 1 divided by R minus 1. So the required sum will be 2 into 2 raised to power n minus 1 divided by this 2 minus 1, that is just 1. Okay. And the second one, this first one is just n into n plus 1 into 2n plus 1 divided by 6 plus this. Okay. Altogether, this is the required sum. Okay. Next question is find the sum to n terms of 2n minus 1 whole square. So open it. It will be 4n square minus 4n plus 1. So this is Sn is this. Okay. So summation will be 4 times summation n square minus 4 times summation n plus summation 1 n times. So that is again the same thing, that n is added, 1 is added n times. So 4 times the formula for n square minus 4 times the formula for these n plus 1. Okay. Open it, a bit solution required, and then I can go for your this. By opening it, I'll get the result as n by 3 2n minus 1 into 2n plus 1 divided by 3. Okay, and into n 2n minus 1 into 2n plus 1 divided by 3. So I hope that the exercise based upon sum 2 in terms of special series is clear to you, and you will be able to solve the questions based upon this concept. Thank you so much.